Hello everyone. We have studied in first unit about different types of robots. We have also studied about the classifications based on the configuration as well as based on the control methods. We have also studied about trajectory. We have also studied about different types of joints which are available in robot configurations. Now we will study the dynamics and kinematics behind movement of various robotics arms. First and foremost, in second unit, we are going to learn about coordinate frames. We are going to learn about coordinate frames. Then we are going to study about the concept called mapping. Now, first of all, we will start with coordinate frames. What happens in case of coordinate frame? For example, you consider a 3D space. In a 3D space, if you keep any object, if you want to describe the object by means of vector representation, then that will be considered as the representation about or considering any frame. For example, I have got something in my hand. If we keep some coordinate, okay, x, y and z axis, then the description of this with respect to this has to be identified in order to understand how much rotation or how much translation is required in each and every joints in order to perform some task in robots. First of all, we will consider a block as you can see. Okay, one 3D block we have taken out of a cube. Now, we will say that we have got point O over there. O is nothing but the origin. Okay, then we have got x axis, then we have got y axis, and we have got z axis with us. Fine. Now next, if these axes are termed as a frame, this will be called as the notation of frame, which has to be represented in a flower bracket, as you can see. Now, I have got only one frame over here, so I am keeping the name frame 1 for this case. Now, as the frame consists of three directions or three axes, which is x, y and z, this frame can also be represented as x, y, z frame. Okay. Now next, let us take one point P. Let us consider a point P, which is somewhere in the space, and from O, that means origin of the frame, the distance is vector OP, as you can see over here. Okay. Now next, this OA makes an angle alpha with x-axis. Then it makes some angle beta with y-axis, and it makes some gamma angle with z-axis. Fine. Now we have to represent, here we need to know the concept of vectors. So if you see this, if you just see the distance, okay, the distance of point P, that is straight line distance of point P from along x axis will be called as x cap. That means x cap unit is the distance from point O to point P along x direction. Okay. Similarly, if you consider along y direction, then point P is located at y cap distance or at y cap unit. Similarly, we can find the distance of point P from origin O along z direction, which is z cap. Okay. Now we have given fx. Fx means suppose or px, we can say fx or px. If the point P, we should keep it px. So P is along x direction, that will show the direction cosine. Second, fy or py will give the direction cosine along y direction, and another one fz or pz, if you consider, that will be the direction cosine along z direction. Okay, so you know very well, in a vector quantity we need to have unit, that is magnitude, as well as direction. Okay, so unit is represented with unit vectors like x cap, y cap and z cap, and the direction is represented by fx, fy, fz, or if the point is P, as in this case it will be px, py and pz. Is it clear? Now moving ahead, we will see the coordinate frames. Okay, representation. Now this position and orientation of point P, which we have seen in last diagram, can be represented as vector P, which is also represented as OP. Okay, so that we can tell it as the summation of Px, x cap, Py, y cap, Pz, z cap. Clear? Now we will move ahead. So we will try to understand what is called as frame space notation. In order to identify frame space notation, okay, for this OP or P, we need to have a look at this. So description of point P with respect to frame 1 or frame XYZ can be represented as 1P. Okay, 1P. It can also be represented as XYZP, as the name of the frame is either 1 or you can keep it as XYZ. So XYZP, or you can keep 1P, which is summation of 1PX x cap, 1py y cap, 1pz z cap. Clear? Okay, and it can also be represented, okay, as this form, which is 1p, okay, 1px, 1py, 1pz, or in matrix we can write it as 1px, 1py, 1pz transpose. Okay, so this is what we can represent over here. Fine. Now next, we will see what is called mapping. You can see mapping refers to the description of a point or a vector in space from one frame to another frame. Say for example, in the previous case we had only one frame. Now if you have 2 or 3 or more number of frames, you know the description of any point or any object with respect to one frame, and you need to know the description of the point, same point or same object with respect to some other frame. Okay, so all are unknown. About one frame, you know the description, so you have to convert it into other frames, right? So that is called as mapping, or that procedure is called mapping. There are 3 ways to perform mapping. Number 1, suppose we have got 2 frames. I'll show you next diagram. Okay, we have got 2 frames. Suppose frame 1 and frame 2. Okay, so frame 1 and frame 2 both were, for example, in same line. Okay, means frame 1 x-axis, frame 2 x-axis, both are coinciding. Similarly, y, z in same axis or parallel to each other. Okay, now frame 2 we will rotate with respect to point O or origin of frame 1. Okay, where the origin of frame 2 also be in same point, which is point O. Clear? Now next we will see second point, where the frame has to be translated either along x direction or along y direction or along z direction parallel to the previous frame's axis. Okay, and third is frame 2 will be rotated as well as translated. Okay, so these 3 possibilities are there. I will give a brief intro about the first point. okay, which is case 1. That means frame 2 will be rotated at some angle say theta with respect to frame 1, keeping the origin at same point. Now you can see here, same block we have chosen, and then we have got the point O, which is the origin of both the frames, frame 1 and frame 2. So we are first considering the x-axis of frame 1, then y-axis of frame 1, and then we have got z-axis also of frame 1, right? And then we are representing, as I have said, that frame 1 is like 1 in flower bracket or second bracket we have to represent, or in xyz also we can represent. Next we have got the point P, okay, for which we have to do mapping, okay, point P which is located at any point in the space, right? And you can see OP also, right? OP also we can see, that is a vector, right? Now we, as I said, that we have to do rotation, okay, means for example this frame only is there, we are rotating it, or two frames are lying, we are rotating it, okay, right? So if we do the case, then what will happen? So we will see, first we will see that Z, once Z is rotated, X, Y, Z all are rotated at some angle theta. Okay, now you see, previously X axis was there, now it has moved to some other place after rotation, which is named as U. Okay, then Y axis, after rotation we have got its position in V or along V direction. Similarly Z, okay, Z we have got in the direction of W, okay, in the direction of W, right? So this is another frame which we have received after rotating the first frame, keeping the origin in same position, okay. Now you can see, previous one was frame 1 and another next one is frame 2, which has also to be kept in a flower bracket, okay, right? Now you can see here like U, V and W, as I have said. So these are the three axes we got after rotation of it. Now our next work is we have to find the description of point P about frame 2 when we know the description of point P about frame 1 in the form of matrices. So that one we will see in the next classes.